Hello, everyone. We are going to begin with the Canadian sessions. And we have Deval Pandya from Vector Institute, Director of AI Engineering. Welcome, Deval. How are you?
Thank you. I'm very well, and I'm super excited to be here. Thanks for inviting me. I have to say, this is my first Turkish forum that I'm presenting to, so I'm a little bit nervous, but we'll get there.
Don't be nervous. I'm sure it will be great because we're going to talk about climate change and AI, and it is a really important topic to talk about, and we have some other sessions that we touch upon this, and we are really excited to hear your thoughts about that. You can share your screen and we can begin.
All right, thank you. Let me start. Can everyone see this okay? Yeah,
yes.
Okay. So thanks for that introduction. As mentioned, I head the AI engineering team in Vector Institute. Vector Institute is one of the leading AI institutes in the world. It is one of the 3 major AI institutes in Canada. And the mission for us is to further the boundaries of research in AI. And for me, particularly me and my team, the goal for us is to take this breakthrough research and apply it to solve real-world societal challenges. I'm personally super passionate about applying AI and machine learning to solve one of the biggest challenges we are facing as humanity right now, which is climate action, using one of the most transformative technologies, which is machine learning and AI. So before we get into the AI piece, I wanted to start with a few slides talking about climate change in general, right? And so this is just a small snapshot of Earth Overshoot Day. And I'm pretty sure a lot of you know about Earth Overshoot Day, but for those of who this is a new concept, the idea is after how many days we are actually using or going over the allocated resources to support the world as it is right now. And as you can see in this graph, that Earth Overshoot Day is coming earlier and earlier. So this year, it came already in August, and which means that by August 22nd, but around that time, we pretty much used all of our allowances as humanity for the year. And now we are kind of on borrowed times. And this is huge because this affects everything. It affects nature, it affects our future generations, and it affects sustainability going forward for the world. So climate change is happening. I don't think there is a lot of debate about whether climate is changing or not. Most of the debate, as we see both in industry and academia until recently, was around whether the climate change is happening due to human activity. And that is to say, if we change courses, can we do something about it? Or this is a natural phenomena which is pretty much unaffected by humans, and so there's not much we can do. And there is staggering evidence that climate change is happening due to human activities. And so when you look at the graph in pre-industrial era versus right now, we see that total CO2 emissions have been increasing. And CO2 is just one of the greenhouse gases, but then a lot of this reporting is done in terms of greenhouse gas equivalent. So there are other greenhouse gases, but they are measured in terms of CO2 equivalent effect of them. And we see that the CO2 reduction is possible, right? So one of the things which I do want to kind of emphasize here with the graph here on the right is we still can manage 1.5 degrees of increase compared to pre-industrial era in global temperature if we take action now. I cannot emphasize the now part of this. I think the time to take action best time was yesterday, and better time is today. And so we have to do something right now. One of the most important graph here, I think, is around solar activity and temperature, right? And so this is the middle graph here, which is very interesting because as you see somewhere around the middle, the solar activity is not really changing that much. If you take, say, a mean here, the solar activity is remaining pretty much the same, but the temperatures have been rapidly increasing. And this is a big evidence that something beyond natural phenomena like increasing solar radiation is at play here, and a lot of it can be attributed to human activities. Also, putting climate change in context of UN Sustainable Development Goals, I don't think climate change is a problem alone in itself. And now I think it's pretty evident that climate change is affecting a lot of other challenges across the board, right? And so, say, sustainable growth is being affected by climate change. Employment is affected by climate change. Universal access to electricity. And so decarbonizing our electricity or power sector, as well as same time, making sure that power and affordable energy is available for everyone. Or what we are seeing in Europe right now is a big evidence and proof of that it's a huge, complex issue. On one hand, everyone needs energy, and energy plays a key role in the society, in day-to-day lives, right? At the same time, we need to decarbonize as quickly as we can. And so there are various sustainable development goals which are interconnected here, and that's something which I wanted to emphasize with this. And so it's a much bigger problem which affects a lot of other challenges, and so it should be seen in a systemic view versus an individual problem view. So we are about to start the COP27 soon, but I think COP26 was a landmark deal, and there are some implications of what was the outcome of the COP26, which happened last year. So big one was initial coal phase down, and so initially it was framed as a phase out of coal, but then rapidly developing economies like China and India, they wanted to have a less stringent clause, and it said, okay, no, we are going to phase it out and phase down versus completely out, right? And so that's one thing. To do that, what does it mean, right? So in places like India and China, coal currently plays a big role in energy access and reliability of energy system. If we really want to phase down coal and natural gas, a big part of that is going to be deploying as much renewables as possible right now without affecting the electricity system. The other big outcome, which I was very much pleasantly happy about, is the methane pledge. 100 plus countries committed to reduce emissions by 30% by 2030. While the reduction doesn't seem that huge, the short-term pull down on methane can be significant. And before joining Vector, I spent almost a decade in energy industry, and I can tell you that methane is a huge challenge. It is also way more potential in terms of greenhouse gas effect compared to carbon. And the big challenge is a lot of the times we don't even know that we are kind of seeping methane into the atmosphere. It doesn't come only from the energy kind of sector, like agriculture is a big kind of source for methane emissions. And so we have to identify and eliminate these methane sources if we were to reach these reduction targets. The other big one, and this was like landmark in a sense that for the very first time, there are now international rules on carbon trading which are being proposed. And this has been in the talks since decades, actually, about how we can collaborate internationally in terms of carbon trading, and what will the markets look like, and how can we consolidate and harmonize this credit system across the globe. And this brings in a challenge of understanding this carbon emissions at a much more granular level. But this also forms the foundations of what I was just mentioning in my previous slide about this is a global problem and it needs a global solution. The other three things, which I think deforestation is a given, right? Now again, more than 100 countries, which represent almost 85% of the world forest, agrees to end deforestation. But only pledges are not enough. And to stop deforestation, we need technologies where we can actually, one, reverse the effect of deforestation, wherein reforestation and afforestation efforts should be ramped up. At the same time, we need to find almost in real time if there's illegal deforestation happening and things like that. Another big one was financial institutions, including former Bank of England governor. They brought together a bunch of international banks and institutional investors and insurers into committing $130 trillion in sustainable investment. And this is huge, right? And so If you think of it, the carbon economy, this is bigger than the current carbon economy. And to get to that net zero by 2050, we need rapid investments, both in innovation, but also in rapidly scaling the technologies which are already available. And this commitment is huge. And so even here, investors are interested in is how can we accurately quantify the risk affected by carbon, and how can we create a new carbon credit generation system which will help us deploy this capital in the most efficient way. One of the things which I was hoping for, but did not happen, and hopefully will happen in next few months and next few weeks at COP27, because there was no agreement in loss and damages. And there was for the first time, at least, there was a recognition that not every country in the globe is affected by climate change equally. And a lot of the countries have historic emissions much, much higher. Like most of the developed countries like US and Canada and Australia and UK have historically have accumulated so much emissions. And so there has to be some mechanisms to help other countries adapt with climate change, because climate change is a global phenomena, and it doesn't have just local effects. And it will become critically important. We are seeing so many catastrophic events happening, which can be scientifically proven and correlated with changing climate. Like from my personal experience, before I moved to Toronto, I was in Houston for 7.5 years, and Houston is flood prone. That's not a new thing. But in 7 years, we had 300-year floods, which is crazy, because this essentially, like 100-year floods means that it happens, the likelihood of that level of flooding happening is 1 in 100 years, and we had 3 in 7 years. And so these catastrophic climate events are getting more extreme, and we need mechanisms to mitigate the effects of climate change. So some of this is going to happen, and how do we adapt to it is going to be a key as well. Now, going on to how machine learning and AI solutions can help. And so let's dive into some of this, right? So AI can help address many part of this climate action, right? And so the way I like to kind of categorize this, just for making sense, is there's a huge bucket of mitigation, and this is where you're trying to avoid the emissions in the first place. These are things around like efficiencies and optimizing renewable energy production and reducing your energy usage and creating better emission systems and accountings and trading systems. Precision agriculture, where you will have to produce more food with less resources. And so how can we use some of this precision agriculture to address that challenge? Discovery of new materials, which will rapidly help with adoption and efficiencies in the energy sector, but also in heavy industries, right? Like a lot of carbon emissions comes from steel and cement manufacturing. And so how can we kind of replace or make those processes efficient, but also replace some of those materials with newer, more sustainable materials? The other bucket here is adaptation. And so this is about understanding the climate risk better, improving the climate and weather forecasting models, and then new ways of adapting and using different microbes and regeneration mechanisms to adapt and regenerate our nature in general. So now I'll be sharing like a few kind of we don't need to go into details about some of the companies which are trying to kind of address this, but climate data and analytics, AI has been used very heavily to understand Scope 3 emissions in supply chains, and understanding human behaviors and even affecting human behaviors to help get better at reducing your emissions, right? And even in things like methane detection using satellite imagery, AI has a big role to play. And as computer vision models become more and more complex and efficient, they are being deployed out of the box. Like, for example, just one of the papers recently published, I'm saying recently, but it's been a couple of years now, showcases a benchmark on how machine learning and satellite images can help reduce carbon emissions. Next piece is around climate, AI and climate adaptation. And so this is around how we can quantify the risk better and understanding the climate risk exposure. And because this is a complex problem, we are seeing a lot of graph-based neural network methods coming in play here. I would joke that in the energy system, when I was in the energy sector leading the renewable energy, data science and machine learning teams, I would joke that you could break down pretty much every single energy problem into two buckets. One is if you can forecast things better, and then if you can optimize things based on the forecast, you will solve like majority of the challenges around efficiencies and reducing carbon footprints of the energy system. And so we are seeing now a lot of most advanced deep learning based methods, which are enabling way more sophisticated forecasting using multimodal data. And there are new products being built based on using AI. And I'm sharing like a few say recent advances, which is where AI is being used to predict floods, and then also determine evacuation plans, which are most efficient. Deep learning has been used to detect extreme weather patterns before they form. And so that ways you can, again, you can adapt better and so on. The other big piece is decarbonization. And this is where even vector researchers are doing a lot of work. So one of our researchers, Alan Espoguzik, he is a world-leading researcher in using machine learning and AI for finding new materials and using machine learning for energy materials and materials discovery. These new materials are key to a lot of things, even beyond climate, and even are being used in terms of, say, can we find materials which are regenerative in itself? Can we find new materials for more efficient batteries and power storage? Can we find new materials recently I saw the advancement in transparent solar panels and so on. The other big piece which I am a lot passionate about is around using AI and machine learning to complement on-ground measurements, which can help us understand the afforestation, reforestation, and nature-based solutions effort better and help us focus those efforts in places which need the most. And then there is a huge chunk of work that needs to be done in energy transition. Energy comprises of majority, if you combine energy and transport, it comprises majority of the global emissions. And there has been a lot of context in this, and you can actually simplify that by just a simple kind of theme or goal in the energy system. And that is, say, if you can electrify everything, and then if you can greenify your electricity supply chain, you will solve 80% of the carbon emissions for most part of the world. And so there are a lot of AI and machine learning applications in this complex world of energy, where you want to optimize renewable energy production, where you want to manage the grid better, and even design the grid of the future, where we think that the future grid is going to be decentralized, but it's highly digitized with advancement of smart meters and things like that. We now have understanding of energy usage way better than what we had even 5 or 10 years ago. And so how can we harness this data and use more complex machine learning models and AI models for forecasting and optimizing the whole energy system is an effort which is ongoing. And there are various, like a lot of companies trying to address this. Both startups and huge companies are in this. The other one is, which is more closer to consumers and consumer behavior, is how do we reduce our consumption, right? And so how do you optimize your energy usage? How do you optimize energy usage for building products, but also in terms of how we can use precision agriculture and use alternative methods to plant-based like proteins versus in our food system versus animal-based proteins, which are proved to be much more GHG intensive. And various efforts has been made in terms of building smart homes and smart cities, which are way more energy efficient using artificial intelligence. Finally, I know if you are interested in this space where you can apply and you are interested in using AI and machine learning for addressing climate change, there are various brilliant organizations, even beyond Vector, which are doing a lot of work here. And I would like to give a shout out to a few of them. One of them is Climate Change AI, which is very much focused on researchers globally. And they do workshops in most of the large machine learning conferences, actually twice a year, one in NeurIPS, which is happening in December, another one in ICML, which happens mid-year. There are also a lot of startups, but then there are huge grassroots-based communities like Work on Climate, Climate Action Tech. There are job search portals like TerraDo and Climate Base. And then there are various portfolio companies of some of the venture firms who are interested in this. With that, I will end here and open it up for questions.
Yeah, we are not taking questions, but I want to thank you, and I'm sure we will talk about climate change cases, and I think there also be a lot of successful stories as well, and this will be a beginning for you to introduction to the Turkish ecosystem, and I'm sure we will talk about these cases in the future as well. And we also talked about energy transition projects in different sessions, and it is one of the most important things I believe, especially for the private sector companies, and also without reducing the resource usage, we won't go anywhere beyond from where we are right now. And I want to thank you, and hope to see you in the next events. And